All right, so today we're going to start talking about retrosynthetic analysis of addition products. It sounds like a lot, but all that means is the retro part just means we work backwards. Um, it's a whole lot of title. All right, so retrosynthetic analysis of carbonyl addition products. So we're going to start out with this one problem, and we're going to work our way through this problem, and then we're going to take what we do here and apply it to some other
Dr.
problems.
Russell,
Yes.
can you go up a little bit for a second?
Yep. Mm-mm-mm-mm-mm.
Got it.
All right. So when we talk about like retrosynthesis, what we're literally talking about is working backwards, like starting at the product and working our way back to the start material. All right. So if you look at the example that we have here, this is my carbonyl addition. And keep in mind, this is all under the umbrella of addition of organometallics to carbonyls. And you're either going to add to a ketone, an aldehyde, or an ester. All right. So for the case of the alcohols, we're going to consider that we add it to either a ketone or an aldehyde. All right. The ester, I don't want to do that, but just know that if you did add to an ester to get an alcohol, it would take two equivalents of your organometallic. So 2 parts of a Grignard to 1 part ester, right? We talked about that earlier, a couple of days ago. All right. Oh, let me date this right quick before I forget. What's today? The 8th. Come on, pen. All right. So if we look at that problem, we need a strategy. Now I sent y'all a video to watch a couple of days ago about the strategy for retrosynthesis. Somebody tell me if you watched it. Hopefully you did. If you watch that video, what's the first thing you need to do to that product in order to start working backwards?
Get rid of the H, right?
Get rid of the proton, because the reason you do that is because that's the last thing that you do in the forward reaction. The first thing you do going forward is add the Grignard, and then in the second step you add the proton. So working backwards, the, the first thing you need to do is reverse the last step. So that's my strategy, is to remove H plus from OH, right? That's what I want to do. And so let me move this out of my way. Right, remove H plus from O2, OH, I'm sorry. And so now let's see what that looks like. So if I take off the proton here, right, what I'm left with is an oxyanion, which should look like this. Oh, I'm gonna put the electrons around it, right, like that. Right, it's that simple. And if you can't fathom just plucking off a proton, you can always think about using a base. Just put a base over the arrow, and then that way you'll know that
Is
you're doing a
beating in the park.
proton transfer. Say that again. Was that a question? All right. So once you get to this step, now you're trying to get back to your star materials. So what's the What's the opposite of addition? Learn this in part 1, I think. Got a lot of A students on here.
Elimination.
Elimination.
Elimination, which is the next step in this strategy for deconstruction or this retrosynthesis. Right. So the first step is the loss of protons. Second step is to do an elimination. The question is, which part do you eliminate? Right. Because when you do an elimination, you're going to end up with a pi bond, and you're also going to end up with some leaving group leaving. Well, for this question, it's obvious, right? The Grignard is actually given to us over the arrow. So that's how. So now we know what to break off from that oxyanion, right? So we're going to do this. We're going to put an arrow here, and then we're going to put an arrow here and break that carbon-carbon bond. Any questions about that? Right, so this is my elimination step. That's my elimination step. What do I get from that? Right, keep in mind what's not shown, but what is here, right? There is a hydrogen here. So, and I'm gonna give you a little like rule of thumb for the products to know whether or not you started with an aldehyde or a ketone. But what should I get from that elimination step? And this is a carbon right here. Now, don't lose that. Right, that's a carbon, that's a carbon, that's a carbon. Every vertex is a carbon, unless there's another atom there. All right, what should I get from that? Should I get this?
Yes.
And then, well, let me not do that. Let me keep the colors consistent. And that, is that right?
Right.
All right, and so this, the piece that I kicked off, that's what becomes, or that's what I can write as my Grignard, because that carbon is negative. So that means I can stick a magnesium on there with no problem. So that's my Grignard piece. Right, and the other part is my carbonyl. So if I had to write the carbonyl part, because I already have the Grignard over the arrow in that top example, I would just write this carbonyl in right here. Like that. Questions about that? Any questions about anything?
No, but say if the OH was on like a tertiary carbon, instead of getting an aldehyde as the starting material, we'll get a ketone, right?
That's exactly right. And I said I was going to mention that, but I'm glad you said it. So another, like a rule of thumb. Be quiet. Heard that, right? If you got a tertiary alcohol in the product, then that means you started with a ketone. If you have a primary or a secondary, let me zoom in so I can. That means you started with an aldehyde. Right, that's a great observation. You got a primary, secondary alcohol, then that means you started with an aldehyde. You got a tertiary alcohol as your product now of the addition reaction, and that means you started with a ketone. That's a great observation. And I'll just do, I'll do this. That the product is tertiary or primary, secondary, and then starting material will have to be either a ketone or aldehyde. All right, any other questions? Because we're gonna dive in and do some more examples. Let me copy them so I won't have to try to squeeze anything in. Let's see. We've already done all those. Let's do 3 and 4 up here because I think we did yeah, we did 1 and 2 already. So let's do 3 and 4 here, and then we'll go down and do some other examples. All right. So you can see in the product on 3, right? You have a what? What type of alcohol? Primary or secondary?
Secondary.
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 And so what does that mean for the start material?
It's gonna be aldehyde.
Aldehyde plus whatever your Grignard is. And the Grignard is given. You see that? So the Grignard right here is already given. So you know in the retrosynthesis what you're removing and what you're gonna end up with. Do we need to go through? Well, I'll just put a box over here. All right, so this is what we're gonna start from to start deconstructing. So that's O minus. We'll put some electrons here. And H. And then here. All right, so this is what I'm gonna use as my template to break this thing down back into its start materials. All right. So where are your arrows going in this?
Wouldn't the O form a bond? You would like draw arrow from the electrons to the bond beneath the oxygen,
Yeah, because you want to reform that pi bond, right?
right? And then I would break the bond on the right of that.
To here.
Yeah.
Put the electrons on this carbon right here. All right. Right. So my 2 pieces from that will end up being, I can put it here. This is going to be my aldehyde. Right. And then my Grignard is going to come from this. That's negative, right? So that's where the Grignard is going to come from. All right. So that's the gist of this, the retrosynthesis. You find the intermediate, or you form this intermediate, this oxyanion intermediate, and then you decompose it through elimination. And it's the same for any Grignard product, any addition product, you can decompose it the same way. The thing is, like these examples, and we did this one down in the other a second ago. So
is because like huge companies like Tyson and Purdue and stuff that information so that they can tailor their food and
all right. So we've already done that example.
Yeah, we did that one, but I think on the last one, it was on a secondary carbon, but on this one's it's tertiary, so you'll get a ketone, but that's
Okay.
the only difference.
So what would my intermediate look like to my that I would deconstruct or eliminate from? Did it look like this? Is that right?
Yes.
And then once I put the pi bond in, I can already see what I'm gonna eliminate, right? This is gonna be the part that gets eliminated because that's the Grignard, right? So when I put that pi bond back in, I'm just breaking this carbon-carbon bond like so, putting the electrons on that carbon. So I'm ending up with a ketone that looks like this. Like plus there's too many carbons, sorry. Plus that, right? Which eventually becomes my Grignard.
I have a question. So on the test, are you going to basically tell us what the Grignard is, or do you want us to do it like in the video and like find them all?
No, yeah, we're
Like,
gonna do some. We're about to do some problems like that right now. So you may or may not have the Grignard. You may have to come up with a couple of ways to do it, because sometimes you got multiple ways that you can make a product. So let's do some of those right now. That's a great question. Actually, let me see. It's not there. It's on the next page. The next set right here. Let's take some of these problems right here and work through them, right? Because these are all retrosynthetic problems. Let me copy this and put it on another page because there's not enough room to write the answers out or write the mechanism out and all that stuff. Let's see. Yeah, that's a great question. Sometimes you're not going to have the Grignard that you started with. So you need to, like, let's say, for instance, number one, where number one says that develop or propose 3 ways, right, to make A, or 2 ways to make C, right? And to be honest, 100% honest, like a problem like E, right, that can come from Grignard addition. Obviously, you can add the phenyl magnesium bromide or something like that. Matter of fact, we'll do E. But that could come from another type of reaction too. It can come from a reduction, which we haven't talked about yet. So we're gonna stick with the Grignard. So let's do A. Let's do D, and we'll skip F because F is another reaction where you add. Actually, let's do F, but we'll only do it with the Grignard addition. There's another way to make F that doesn't involve a Grignard, but we're not gonna do that. All right, so let's do A, D, F, and C. All right, so if we start with A, right, what does my intermediate look like? I'm going to be working backwards. That's what that kind of weird looking arrow means. It means that you're doing retrosynthesis. So what is that? What is the first thing I need to do?
Make your oxyanion.
Yeah, so remove H plus, right? That's my strategy. And I don't deviate from it, right? I start with alcohol, I'm working my way backwards, right? The first thing I'm doing is taking off the H off of oxygen and making it into an anion. All right. What type of alcohol is this? Is it primary? Is it secondary? Is it tertiary? It's tertiary, isn't it?
Right.
If it's tertiary, that means that my starting material is going to be a what?
Ketone.
A ketone, right? So these are things you already know. So once you have those little pieces of information in place, the next thing to do is just apply it to the example that we're looking at, right? So if I remove H plus, what should I get? Can somebody draw that in? Any brave soul? Don't all draw it at once. Now it might flood the screen.
Sorry, I was trying to do it. Hold on a sec.
All right, take your time. Okay, good. So we're starting with that. All right, so I'm gonna put that here so I can keep. So this is what we're starting with. Good. Now the question is, what do we eliminate? In this case, it doesn't matter, right? It's up to you. You can eliminate this side. And I think as an example like this in the video with multiple pathways, you can eliminate the methyl group right here or the methyl group right here. Since the two methyls are redundant, we'll just stick with one. All right, so we'll just do this one. So which one do you want to eliminate?
Let's do the top one first.
The top one. All right. So if we do that, we can put the arrows in like so. Right. Boom. Put the pi bond back. And then keep in mind at the end of that line now, that's a CH3. So I'm going to put these electrons here. Right. So I'm going to end up with this as my ketone. I'll write the CH3s in. Plus, what? When did I go from to limited zoom? Sorry about that. I always will. No mind. But they change stuff every freaking day and don't tell you. All right. So that's that. And then of course this becomes the Grignard, right? If it kicks us out, just stay logged in. I'll just log back in because we've never had this problem. I don't know what happened. I can just stick a magnesium here, right? And a bromine, boom, and now I have my Grignard, right? And it's important to write it that way, right? The magnesium is covalently bound to the carbon. That's what makes it an organometallic. So I got to write it in this order. All right. Any questions about that? All right. What about if we did it the second way, where we took off the ethyl group? All right. So this is this group right here. This is a CH2 CH3 group. Would it look any different other than different arrows?
No, it'd be the same.
Same thing, right? I'm just going to push a pair of electrons here and break this bond here. Right? And so that's going to give me this ketone. I'll write in the carbons. Plus, I'm going to write this out, CH2, CH3, and then a pair of electrons on that carbon, and that's negative, right? So that's my green, that is where my green is going to come from. So it'll be Mg, CH2, CH3, Br, right? So that type of problem where you don't have the starting Grignard, you have to, it's your choice as to which part of that becomes the Grignard. But the fact that we started out with a tertiary alcohol means that one of the starting materials is going to be a ketone, the other one is going to be your Grignard. All right, questions about that? No questions. All right, let's do another one. Let's do C. Let me add a page. And let's see. Come on, man. Do what I told you. All right. All right, we're doing C now. So it says two ways, and you can see immediately that it's a secondary alcohol. So that means that one of your start materials is going to be a aldehyde, good, and one of them is going to be the Grignard. Let me fix this up. That looks sloppy. So this is a secondary alcohol. So it had to come from an aldehyde. All right. So first step, take off the H plus off the alcohol. So I'm here. Let me get my my geometry right. So this is O minus now. All right. Which side do you want to knock off first? Because it's the same concept, right? You got the secondary propyl group on the left, and then you have a methyl group on the right.
Let's do methyl group on the right.
All right. So then boom, we just same process, right? It's the same strategy every time. Once you get to this intermediate, then you push the electrons to do your elimination. All right, so I'll draw it down here. All right, so you have that plus this. Right. And so with that, you know that this is going to eventually be your Grignard. Right. And if you did it the other way, where you took you took off the secondary propyl group on the other side, it's the same process. And I'll tell you what, this style is gonna make me cuss one day. Right, same process. The only difference is the fragments for the star materials are gonna be different. All right, so what should I get from that?
You're gonna get an aldehyde,
Mm-hmm.
and you're gonna get
Have to
the
skip
little
that. So this is here, right?
right.
That plus this piece with a negative charge on that secondary carbon in the middle, right? And that
Right.
eventually, you know, that's where your Grignard is going to come from. That's the precursor to your Grignard. All right. I don't believe this. I don't know when this thing got downgraded to regular Zoom. It must have happened over the weekend. All right. So what I'm going to do, we got 19 minutes left and 1 minute left here. I'm just going to log out, just stay logged in. I'm going to log back in, and we'll continue what we're doing. I mean, I got